We live in a space age where satellites contribute discreetly to our well-being. Weather forecasts, ATMs, GPS navigations, and long-distance communications. All of those depend on satellites a few thousand kilometers above our head. To launch all those satellites, we need rockets. At launch time, 85% of the mass of the rocket is monopolized by rocket fuel. We can't change the laws of physics. The rest is structures, propulsion system, and payload. We do everything we can to reduce the mass of the structures of rocket and to consequently reduce the mass of fuel used. To achieve that, we can change metal parts with parts made of composites, but it's not that simple. Bringing composites and structures like that bring new complexities. For example, solutions to join together metal do not work well with composites, so we need new solutions. The aerospace industry foresee that resistive welding could be an efficient method to join two composite parts together using a resistive heating element. Unfortunately, the problem with that solution is that the resistive heating element stays within the weld after the fact and affects its performance. So, here I come. My project is to produce a resistive nanocomposite to replace the metallic resistive element within the resistive welding process. A nanocomposite is actually composed of plastic and nanometer-sized particles. Those particles are about 10,000 times smaller than a human hair. For my project, I'm using carbon nanotubes. Carbon nanotubes are structures of carbon atoms arranged in a tube as shown in figure 3. Those, when you mix them with plastic, you get a drastic change in properties. For example, we can make electrically conductive plastic. For sure, we don't reach conductivity up to those of metals, but that's not the goal. That's not what we want. But a poor conductor is actually a good heating element. So if we replace metallic resistive heating element by my nanocomposite heating element as shown in figure 4, we can reduce the mass of rockets and reduce their impact on the environment. Doing so will allow to produce cheaper rockets and greener rockets. Each ton of fuel that we save each ton of mass that we deduce from the structure of the rocket saves about 6 tons of fuel. So with these new manufacturing techniques, it will be possible in the future to push even further the limit of space exploration. And who would have thought that using something infinitely small would have allowed us to reach the infinitely big? Thank you very much.